class, welcome to math. Today we are going to look at chapter 4, lesson 1, which is talking about composite and prime numbers, and also we're going to look at the rules of divisibility. So we have our definitions for this lesson. We have divisible is a number that can be divided by another number equally with no remainder. Composite numbers are your numbers that can be divided by one itself and then an additional number, so more than just one in itself. Prime numbers are numbers that can only be divided by one in itself. Looking at the divisibility rules. We have rules that apply to every number for 2, 3, 4, 5, 6, 9, and 10. So if you remember these rules, it'll be easy for you to know if a number is divisible by any of these without having a remainder. So 2, if the last digit is even, it would be divisible by 2. 3, if the sum of the digits is divisible by 3. So that just means if you add the digits together, whatever the digits are, like 39, you would add 3 plus 9. And if 9 is divisible by 3, then the 39 is divisible by 3. 4, if the last two digits of the number are divisible by 4. And we will look at some more examples of these and apply them to a couple of numbers in just a few minutes. 5, if the last number or digit in the number is 0 or 5. 6, if your 2 and 3 are yeses. If the number is divisible by 2 and 3, then it's also divisible by 6. 9, if the sum of the digits is divisible by 9, then that number is divisible by 9. 10, if the last digit is 0. Tell whether the number is divisible by 2, 3, 4, 5, 6, 9, and 10. So we have the number 48. So for 48, I'm going to look at 2. 2's rule is if the last digit, which would be the 8, is even, then yes, it's divisible by 2. So yes. 3, the rule for 3 is if you add the two digits, 4 plus 8, 4 plus 8 is 12. If 12 is divisible by 3, then 48 is divisible by 3. So yes, it would be 3. 4, if you just look at the last two digits, which this happens to be a two-digit number, so 48 is divisible by 4. So yes, we can add the 4 there. 5, if the last digit is 0 or 5, which it is not, so then that means 48 is not divisible by 5. 6, if 2 and 3 apply, meaning you have a 2 and a 3 already on your list, then yes, it's also divisible by 6. 9, add the digits together again. 4 plus 8 is 12. 12 is not divisible by 9, so therefore 48 is not divisible by 9 either. 10 is if the last digit is 0, which it's not, so it's not divisible by 10. So this number is divisible by 2, 3, 4, and 6. Let's look at another example, 36. For 2, the rule for 2, if the last digit is even, which it is, so it's divisible by 2. 3, add the digits together. 3 plus 6 is 9. 9 is divisible by 3, so therefore 36 is divisible by 3. 4, we look at the last two digits, which happens to be just a two-digit number. We know that 36 is divisible by 4. 5, if the last digit is 0 or 5, which it's not, so it's not divisible by 5. 6, if you have 2 and 3 already in your list, it's also divisible by 6. 9, we add our digits together. 6 plus 3 is 9. 9 is divisible by 9, so therefore 36 is divisible by 9. And then 10, our last number, or digit in the number is not 0, so it's not divisible by 10. So 36 would be divisible by 2, 3, 4, 6, and 9. Tell whether each number is prime or composite. Remember, our prime numbers can only be divisible by 1 in itself, like for 13, 1 and 13 only, no other numbers. For composite numbers, they would be numbers that are divisible by 1 itself and then some other number. So for 13, you have to think, can I think of anything that I can divide 13 evenly by other than 1 and 13? I can't think of any other numbers. I can't divide it by 2, 3, 4, 5, 6, 7, 8, 9. There are no other numbers. So that would make this a prime number. It's only divisible by 1 and itself, 13. Let's look at 44. We know that 44 is divisible by 1 and 44, but can you think of another number that 44 would be divisible by? 2. 2 goes into 44 22 times. So 22 and 2. Since I have more than just 1 and 44, 1 in the number itself, that makes this a composite number. So this one would be composite. That one's prime. 18. Can I think of a number other than 1 and 18 that I can divide into 18 evenly? Yes, 3, 6, 2, 9. There are lots of other numbers, so that makes it composite. And then 29, can I think of anything other than 1 and 29 that'll divide evenly with no remainders into 29? So I'm thinking 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 15 times 2 is 30, so I'm going over there. So no, this is a prime number as well. Okay, here's our list of prime numbers that are highlighted in the yellow on a number chart 1 through 100. All of these, like 2, 3, 5, 7, the ones in yellow are all of your prime numbers in the number chart 1 through 100. The ones that are not highlighted, like your 4, 6, 36, and so on, those are considered composite numbers. Now 1 itself isn't really considered composite or prime. So we're just looking at the white ones other than 1 are your composite numbers, and then the yellows are your prime numbers. We will work more on prime and composite numbers and the rules of divisibility in class.